Today we're looking at the Uni-T UT8805E that was sent to me by Uni-T to take a look at. No money has exchanged hands and I'm free to say whatever I want about it. This is a digital multimeter with 5.5 digits, 200,000 counts. This thing is absolute nuts for the home gamer, and actually it comes at a reasonable price for what it is. As with a lot of the Uni-T gear that is more aimed for the pro market, it comes with a certificate of calibration, which is traceable, with the calibration of all the devices used to test it. And I'm going to rattle off some specs on this thing, but really it's something that you have to go take a look at yourself. So the link will be in the description. So it's 200,000 counts. It has dual display modes. It can go up to 1000 volts DC, 750 volts AC. 10 amps AC and DC, up to 10 meg ohms in 2-wire or 4-wire mode, up to 2 millifarads of capacitance testing, 1 megahertz of frequency testing. It's got historical data, 1 gig of NAND onboard stuff. It has control software for your PC to control it with. This thing is just absolutely insane. I typically go over what the precision of these things are, but I think in this case I'm just going to link you to their website where they have the full specs, because it's pretty intense. Not only do they provide a just sort of like baseline accuracy, but they also tell you what the 90-day accuracy is after being calibrated and the 1-year accuracy is. Also a temperature deviation accuracy. Just to give you an example, in the 20 volt range, it is plus or minus at the 90-day range, plus or minus 0.008% of the reading plus 0.004% of the range. And for the 1-year rating, it's 0.01% of the reading plus 0.004% of the range. So I'll let you go check that out yourself, link in the description. For now, let's just have a play. The test leads that come with this are these Uni-T branded 16 amp capable test leads. They have the straight ends on them to go right out of the front panel here. They are silicone wire, very, very bendy, but yet if they can take 16 amps, they're a little bit stronger, a little bit thicker than most multimeter leads. They also have the red security caps. I can't remember if they have the extra cat protection caps on them, because I did an unboxing video and I tend to tear those right off. So I'm not sure if they're included, but there's definitely a groove that you can see here to, to install some if you really need them, but I take them right off. The device itself is rated Cat 2, 300 volts, and it being Uni-T, you can trust that this is accurate. The rest of the accessories you get with it, you get these little croc clip leads, very likely to do the 4-wire current sense stuff. You can't have a 4-wire measurement without 4 wires. You get one of these printer cables. You got one of these K-type thermocouples. You get a D9 connector or wire cable. You also get a little bit of their stuff in here. You get the documents download guide thing. You get safety certification. And you get the results of the calibration test. I don't read Chinese, so I'm not quite sure, but you can see DCV, ACV, DCI, ACI, and resistance. And then you've got the specs and then the pass-fail over on the side, as well as some extra documentation here. Not quite sure what this means, but you get it. Time for another iteration of the Hobbyist meter gauntlet. Just over to the side here, I'm going to check the voltage with this. But it is very fiddly to move the voltage setting up and down this board. So I'm going to edit it out to just show you the result. If you want to see the full length of how fast this thing reacts and whatever to how fast I connect it, let me know in the comments and maybe I can make a separate video for that. I'll just, do you a separate edit. But here it goes. It's on the 2.5 volt range. Also, we're auto ranging here and the speed is slow. So here we go. So 2.4983. So we're, what?
1.7 millivolts.
Off, which is very little. On the 5 volt range, we are 5.0002 volts DC, so that's
200 microvolts.
off. On the 7.5 volt range, we are 7.4986, so that's what?
1.5 millivolts.
Off. And on the 10 volt range, we are bang on. Look at that, 10.0000. It is so satisfying seeing all these zeros back to back to back. That's pretty incredible. Next up for resistance, all of my resistors here are precision resistors at 0.01% accuracy, except for the 10 ohm, which is 0.1% accuracy. So let's give this a try. I'm going to call them out as I put them together. And here we go. So here's the 10 ohm, 10.088, 100 ohm, 100.061, 1K. Ooh, very accurate. That is 0.31 ohms off. 10K. Very, very close. That is just about 9 ohms off on the 10,000 ohm range. And 100K. That is just about 20 ohms off at 100K. Oh, 10 to 20. Pretty neat. As for very small currents, something's wrong with my Kaiweets multimeter gauntlet because the 1K works. We're expecting about 10 milliamps there. So there we go. Pretty much 10 milliamps. But my 10K ohm one doesn't work. My 100K ohm does though. So this shows you how impressive this multimeter is. You're able to read 100 milliamps on the screen here. Very, very impressive. And as for the capacitors, we have 100 nanofarads 1% and 82 nanofarads 1%. So let's start with the 82. Here we go. Takes a while to charge up capacitors, as is pretty normal. So 81.7, and here's the 100. 99.6, so within spec. Very nice. Let's chat a little bit about the interface on this. So first things first, it has a soft power on-off button. Not too much of a fan of this. I'd rather a big ka-chunk physical power off button. And I'm not sure if there's a software reason for this, like if one of the features requires it to be powered on all the time or whatnot. But it does have a switch on the IEC connector, but that is on the back of the unit. Since this thing is meant to be up on a shelf somewhere, it is a professional piece of test gear after all. So a little bit less of a fan of that. I would rather a big ka-chunk main power button up front here, but that is what it is. The other thing that I think is a very weird choice is that you've got two voltage buttons, so DC volts and AC volts, and then to get to the current, you have to shift DC volt and shift AC volt, which I think is a little less good than what I've seen other manufacturers do, which is you hit volts once, it's DC, you hit it again, it's AC, and then you hit current once, it's DC, and you hit current again, it's DC, or vice versa. And I think that's a little bit better setup than what this is, at least as a usability perspective. I mean, this is usable, it's just not intuitive as to what I would expect. Another thing that's not super intuitive is how you use the microamps and the regular amps. So this hole here is for your current, which is nice. It's fused internally, which I believe is actually a breaker, resettable fuse, because it's not accessible externally. And then, so that's the current between here and here, and the small current, so up to 200 milliamps, is between this hole and this hole. But now here's what's interesting. If you go to measure current, like this, let's go current DC. So I'll go Shift and DC. Notice how my wire here is in the amps range, but we're measuring in microamps. Well, that's because you have to go down here and manually select the terminal. So 200 milliamps or 10 amps. So you actually have to select it like that instead of just, you know, hitting current a second time or whatever to hop into the smaller one. That's a little bit weird. I'm not sure if I'm a fan of that. It's just something I'm going to have to get used to. It's just strange. I actually had to look in the manual to figure out how come I couldn't measure current. And the other thing is, because there's separate terminals, there's no failover. So if you have current coming into these wires here, but you're set to the milliamp terminal, you're not getting anything on the screen at all. It's a completely separate circuit. So it's really hard to see what's going on. Other than that, stuff is relatively simple. The range is adjusted by just going up and down. You see the range up there. And if you're not happy with the manual ranging, you just hit the auto. Auto is the default. I think it works pretty well, but it does mean your display changes a little bit slower if you have a big difference in, if it has to switch ranges basically. So if you know that your voltage is going to be, let's say, 112 volts, well then you leave it in this range here, and then when you power on with your probes, you're going to see it change a lot quicker than if you just set it to auto, and it'll step through all the ranges to find the range you want. Another cool thing is you have your input Z, which is your input terminal resistance. You can set it by just hitting this button, the F3 button right there. You have a relative measurement, and you have historical data as well. One thing that really shows you the power of this multimeter is the math menu. Now, I probably won't go through all the features in the math menu. There's a lot. I'm going to link you to the owner's manual down in the description. But here, if you look at the stat button, you go stat on. Look at the dual display now. So you got your volts DC, but now you've got your minimum, you've got your average, you've got your maximum, you have your span, your standard deviation, and how many samples it took. So if I just go, this is connected right now to the UDP8305S. If I go a little nuts with it and just start changing the voltage all over the place, you can see your min and max values will change, as well as your voltage averages, and your deviation shows you your span, what the whole range was. It's pretty crazy. It allows you to really get a feel for what your power coming in is doing. So if you have a device that draws quite a bit of power, and you need to you know, check if it's affecting the voltage, if you're getting voltage drop, all sorts of things, this kind of stuff can be really useful for that. The math menu also allows you to access a couple different display modes. So you've got the number, you've got the trend graph, which is sort of like a waveform graph. It's a little bit hard to see, but it works pretty well overall. You also have a bar graph, so you've got your dual display here with the bar graph. Now the bar graph, as far as I can tell, doesn't move faster than the numbers, so it's just a visual indicator of what the numbers are doing. And you've got a histogram, so that tells you a little bit more information about where the voltages are and for how long they've been there. So I'm just messing with the dials now. So pretty neat. See, right now it's stuck on 1 voltage for longer, so it's biasing the histogram, and if I move it, there we go. So it's just another way to visualize the data. the multimeter comes with a K-type thermocouple as well. Let me show you how that works, because that's another thing that I had to go to the manual to take a look. So first and foremost, you want to make sure that you have the correct polarity. So positives over on this side, and that goes in this red terminal, even though it's not marked degrees here anywhere. It goes up into that terminal and into the common. And then to go to temperature, it's shift and capacitance. And then if you get OL, like this one is, you have to go to your probe settings and you have to select the probe you have. So this is a thermocouple, and you have to select the type of thermocouple. So it's K-type, and now you have an accurate temperature reading, and I can, squeeze this and the temperature will go up, to show my fingers are, actually my fingers are quite cool right now. But there we go. So this goes up. Now, something to keep an eye on is that, first of all, this thing is internally compensated, so this number should be as accurate as possible. But something to keep an eye on is I actually set this to a K-type thermocouple before this video, and it didn't remember my setting from the power cycle. So that means that very likely every time you go to temperature, after a power cycle, you may have to set that again. Let's see if it'll just remember. So it remembers now. So let's turn it off. And let's see if it remembers if we turn it back on. Okay, shift there. Nope, it doesn't remember. So you have to go back to the setting, back to your thermocouple, and change the type to a K-type in this case. And there we go. So again, something to keep an eye on when you're using this thing is every time you're going to have to reset thermocouple mode. Just every power cycle. So that also means that although this thing can accept a wide range of thermal devices to take a look at, it does also mean that that customizability comes with a cost. You have to set your settings every single time you power off and on. That's something I would like to see improved, because especially since this is a soft power switch. So in principle, the power is still plugged in. So even if it stored these data in volatile memory, I think it should remember at least until it's unplugged, if not permanently. A really cool feature of this multimeter, though, is the 4-wire resistance measurement. So let's try the 2-wire resistance measurement. So you just hit resistance, and here I've got the supplied alligator clips. I've got an 820 ohm resistor plus minus 5%, so it's not very precise, but that doesn't really matter. So essentially, what happens when you go into resistance mode is that it sends a small voltage and current through these wires here, and it measures a relative voltage drop through the leads in order to calculate the resistance and display it on the screen. That means that it's sending voltage and current down the same wires that is measuring from. A 4-wire measurement, though, which this machine can do, will send voltage and current down a different set of wires in order to get the answer. And so I've just got these leads hooked up. They're not supplied. I had to supply them myself, which is fine. And I'll just hook these up to the resistor on the outside. And now I'm going to go shift into 4-wire mode. And there you go. So a little bit more, a little bit different. You actually got a little bit more resistance now that the wires that are measuring are only measuring. It's just measuring the voltage drop directly at the resistor instead of internally as the 2-wire would do. So you get more precise measurements, and that's sort of important when you have so many digits to work with. What good are those digits if they're not accurate? AC volts works perfectly fine as well, and I believe on the dual display you should be able to see the frequency. Yep. There we go. Look at how many digits we have on the frequency. So my wall power right now is at 59.96 something something something. So, basically 60 hertz. That's pretty neat. I think you can also just hit the frequency there if you're just interested in the frequency. Not sure if it'll do it on the AC. It does. So it shows you the same amount as well. And then you can also get the period. So it's the same measurement, but it'll be in seconds instead of representations per second. Time to check the continuity beeper. Oh, so no beeper. That's because it is off. There we go. Beeper is on. So it responds quickly, as you can tell. It does respond, but the beeper is not latching. Maybe if we adjust the threshold. So it's set to 30 ohms. Let's drop that. One. There we go. Can I turn that off? On. Threshold. There we go. Let's see. So kind of a slow continuity beeper there. It's not very fast. Could be due to the leads though. I do have some fancier leads that I'll try in a different video, but this is just looking at what comes with it. Kind of slow. Let's take a look at the diode test function. So here is a 1N819. It is a Schottky diode, if I'm not mistaken. So there we go, 0.2 volts DC. That is the forward voltage. And let's check. This one is a 1N4007. So just a standard, 0.6 volts voltage drop. That's good. So that's kind of normal, but now I'm wondering if it can light LEDs. Oh, I can't really see the polarity of this one. Let's see if it works though. Oh, yeah. So don't know if you can tell, but that is lit very dimly. 1.663 volts DC of forward voltage. And let's see the ultimate test. Can it turn on a white LED? I think that's backwards. Like this and like this. So that is lit. Ooh. So it is lit, but is not telling us the forward voltage. So this will work as an LED tester to make sure it is lit, but it does not read out the forward voltage. I just want to make sure, I'll make darn tootin', that this is not shorting. No, it is not telling us the forward voltage. This should be, around 3 volts. So it must have a threshold where it doesn't work beyond, but that's a little bit weird because this is very clearly lit. Interesting. So after that last test with the white LED, it got me wondering, if it worked but it didn't show the forward voltage, then what is the actual spec? And the actual spec is up to 4 volts. That's what it says in the owner's manual. Maybe it says something different in the accuracy sheet. I don't know, but let me show you something. So here I have a green LED now. So green LED has a slightly lower forward voltage, and it is showing, 1.897 volts DC. So that is working. But then I switch it to a blue LED, and a blue LED should be the same as a white LED, or very close. So here's the blue LED lit, and again it shows open. And let me just show you the interesting part with this. I'm going to leave this actually. Okay, I'm going to pull this off. And here is a Kaiweets multimeter, which is an excellent multimeter, but it's like an order of magnitude and then some cheaper. And then I plug this in. So our blue LED, which is working, right, has a forward voltage of 2.587 volts, which is curiously below the 4 volts that the Uni-T is supposed to do. So I'm not quite sure what the deal is there, but let's see the white LED, right? The Kaiweets couldn't read, the Uni-T couldn't read that either. So let's take a look, and there it is lit, 2.645. So I'm wondering how come this can't show us the voltage, forward voltage on an LED, but yet it can light it. I'm going to be reaching out to Uni-T about that. Taking a tour around the multimeter now. So this is the side, just showing you that you do need quite a bit of depth for this. This is just over 13 inches, just over 33 centimeters, but you are going to need a little bit more because the IEC cable sticks out on the side. This is the side with the ports, so as you're looking at the multimeter from the front, this would be the right side, so the multimeter's left, I guess. And that brings me up to a good point. So right here is the cooling fan, and that cooling fan is quite noisy for a piece of gear. I don't believe any of my other Uni-T gear make this much noise. And it's not like a harsh noise, but it's definitely, you can hear the wind noise rushing through. I have my second microphone here, and I will put it next to the fan and see if you can hear it. If not, I'll just put a note on the bottom and tell you guys that I put it in post. So yeah, as you can see, quite noisy. Starting over here in the back, we have an IEC cable, and again, if you have a really short shelf, you probably want a right angle cable, because there's tons of room to exit between these bumpers here, but it's just right now it's sticking right back. So yeah, if you have not a deep shelf, you're going to want to rectify that. You've got the hard off switch here with a fuse. You've got the voltage selector, which here delivered in Canada, it was already the right voltage selected. RS-232, LAN, and USB. I believe all three of these are because there is software to control this multimeter available. You got an external trigger and a VMC output, and I believe, just looking it up real quick, I believe that this is to let your external device know that the measurement has been taken. You got a Kensington lock, and you've got an externally accessible fuse right there, 250 volts, 250 milliamps. So yeah, not much to see back here other than that. And on the other side, no fan on this side, but definitely a grill here to let the air come through. Also want to demo this arm here to sort of angle the device. If it's up on a shelf, you're probably going to want the arm in the storage position, which is like that. But to adjust it, all you have to do is you pull out on both sides, and then it'll click into place. So there we go, there's one position, and you can have it at a couple of different angles. You can have it all the way up front, so you can pull it out like a drawer. You can have it up top if it's more out of the way. But there's basically lots of positions for this to be stored at, so it doesn't get in the way of your setup. And so that's it for this little 5.5 digit multimeter. The measurement side of it just cannot be faulted. This thing is awesome. It is calibrated from the factory. It is quick. The display is nice and bright. The functions are good. So that aspect of it is perfect. There are a couple of UI things that I would like changed, like that problem we had with the diode test. Also, I'm not a fan of how the buttons are laid out with the, AC current and voltage on one button and DC current and voltage on the other button, and having to set, which hole to put in, and the fact that it doesn't remember the probe. Like, these feel like things that can be fixed with software updates in the future. So let's hope that that can be done. But let's not forget, for $500 US, this thing is a compelling value option. For such a pro-level tool to come at such a low price, I think we can forgive a few of the things. And I'm not sure if I can forgive it, and that's why I don't do reviews right off the bat. I do first looks. So this thing is going to go up on my now test shelf, and this thing will be joining the videos regularly. And we're going to see if I can live with these little problems to have really nice, high resolution, high accuracy display, or if, you know, it's close but no cigar. So we'll see. Hopefully those UI issues are nothing burgers in the future, but that remains to be seen. Let me know what kind of features you'd want me to focus on for the full review so I can integrate them into my daily usage of this thing. Thanks for watching.